So we're going to use our definition of derivative to prove that the derivative of sine is cosine. So we're just going to plug stuff in. We need f of x plus h. So if f of x is sine of x, then f of x plus h is going to be sine of x plus h. So that's that part. And then we're just going to subtract our original function. So I'm going to subtract the sine of x. And I'm going to throw that all over h. So there's our setup. Now what? So everything builds. You got to remember, you've got the sine of a sum, and you've got a nice identity for the sine of a sum, and that's going to help us. So we're going to have the limit as h goes to 0 of the sine of x times the cosine of h plus the cosine of x times the sine of h. That takes care of that part. And then I'm going to go ahead and subtract the sine of x, and that's still all over h. Now what we're going to do is we're going to split this up, and it's not super intuitive yet why this helps, although you do see this, we're going to split this up like this. So I'm going to take these two pieces, the sine of x plus cosine h minus the sine of x, because I'm kind of tempted to factor out that sine of x. Also, I'm kind of seeing this sine of h over h. If I can split that by itself, I can get a 1. Forgot to finish that. So that's what we're going to do. I'm going to take this sine of x cosine h minus the sine of x, that's all over h, and then I'm going to add this. And so by my limit laws, I can make this addition a separate limit and write it like that. Okay, you're like, why am I doing this? It's going to help. Keep going. So here, we can pull out the sine of x from this, so that we'd be left with the sine of x times the cosine of h minus 1 over h. And then this guy here, we'll just let him chill for the moment. Okay. So the reason we're doing this is because we're kind of noticing these identities lurking in here. It's like, oh, wait a second, cosine h minus 1 over h? I know that's going to go to 0. Sine of h over h? That's going to go to 1. So if I use more of my limit laws, my limit product law, and kind of split this up, I can say that this is the limit as h goes to 0 of the sine of x times the limit as h goes to 0 of cosine h minus 1 over h. And then do the same thing from this one, just use my product limit laws to kind of break off that cosine. So it's the cosine of x, limit as h goes to 0 of the cosine of x times the limit as h goes to 0 of sine of h over h. Getting there, getting there. So, limit as h goes to 0 of the sine of x, well, I can plug 0, no, there's no h in there, right? There's no h in there. So this is going to be sine of x, no matter what. And then the limit as h goes to 0 of the cosine h minus 1 over h, we've proven in another video that that's going to be 0. You can prove it real quick right now if you know your L'Hopital's rule, but they usually start us off kind of with that identity when we're first learning. It's going to go to 0. And then this part, limit as h goes to 0 of cosine of x, there's no h in there, so this is going to be the cosine of x no matter what. And then this part here is just going to go to 1 because of our limit rule. And so, sine of x times 0 is just 0. Cosine of x plus 1 is just cosine of x. So our derivative is the cosine of x, like we knew it would be. Yay! So now that we've proven it, we can go and use this fact later to find out more interesting derivatives without having to go through this long limit law process, limit differentiation and derivative process. I can speak. Okay, there you go.